All right, welcome to your first online lesson. Okay. Now today's lesson is going to go a little longer than normal because I'm going to show you how I want you to set up your notes. And your notes are very important. You're going to get a grade on your notes daily, and your notes can be used on any quiz or test that I give, as long as the district allows me to allow you to use notes. You can use it, so it's very important. Okay, and you're not going to have all the anchor charts on the walls because of the way we're going to have to move classrooms this year. So the notes are going to be even more important to you. So I want you to set up the notes as I show you. Okay? All right, so let's get started. Now here is your table of contents. So we're using just a regular single subject notebook. In the very first page, I want you to put a table of contents because I want you to be able to use these notes as a reference. So if you don't remember exactly how to do something, you should be able to go to your table of contents, see what lesson that is that we worked on it, and then you're going to have your page number so you know exactly where to go. Okay? Now today, we're going to be starting off with multiplying and divide by multiple of tens pictorially. Okay, so you should go ahead and put this in your notes for page 1. So now we've turned the page, and if you notice up in the top right hand corner of each page we have a number, and on the left sheet it should say number 1 up in top, and then obviously the next sheet will be 2, and we'll keep going from there. Now the first thing I want you to put in there is starting off with the title, Mod 1 Lesson 1, Multiply and Divide by Multiple of 10 Pictorially. Okay. Now, next thing you're going to do is you're going to write the standard that we're actually working on, which this standard happens to be MAFS 5 MBT 11. And the standard is what is expected of you to learn. Okay. Now, this one says recognize that a multi-digit number, a digit in one place represents 10 times as much as it represents in a place to its right, and 1/10 of what it represents to the left. So in this first lesson, I want you to copy that standard down. Now in lesson 2, we're going to be working on the same standards. So the only thing I'm going to expect you to write down is MAFS5 MBT11, and then underneath of that you can either write out the standard or you can refer to page 1. Okay, but you have to have the standard written down on at least the first lesson that we're working on this standard. Now underneath the standard is a lesson objective. Now the standard is the overall picture on what's expected to you be able to do by the state. Now the lesson objective is what you're expected to be able to do by the end of this lesson. Okay, and with that, what the objective is, the reason pictorially using place value and standard relate adjacent base 10 units from millions to thousands. Now in the 5th grade, we go from the millions to the thousandths place. Now it says reason pictorially. That means we're going to be using pictures in order to understand the standard that we're getting across today. Okay. Next, essential question. How can I use the place value system to understand that in a multi-digit number, a digit in one place represents 10 times as much as it represents in its place to its right, and 1/10 of what it represents to place to its left? And I want you to leave a spot underneath that because at the end of this lesson, I want you to go back and reflect on that question. All right. Now you can see page 2 is blank. We're going to be putting some specific notes in there for this lesson. Okay. And I'll be showing you what it should look like as we go through. So let's get started. Now, the first thing we're going to be doing is we're going to be dividing by 10. And if you notice, this is page 3. Okay, so the first page was listing all the standards, objective, essential question. Page 2 is going to be the notes specific for this lesson. Now, page 3 and 4, I want you to be able to copy at least 1 or 2 of the models. Okay, the example I'm going to show you is going to show about 6 models, but for your notes, I want you to have at least 2 examples of what we did. Okay, in this case, we're going to be multiplying and dividing by powers of 10, so you should at least have 2. Okay, but I'm going to be showing you more than that. So let's see what we're going to do here. Now, this is the first problem we're going to work on. Now, if you notice, it says 1 million divided by 10. Now, the first thing I'm going to do, just to show you, is I'm coming up here to the 1 million place, and I'm going to divide this million up into 10 pieces. Okay, but that represents 1 million. Now, if I was to divide this into 10 pieces like I did, 1 million divided by 10 is going to represent just one of those. So 1 million divided by 10 is going to equal 100,000. Okay, because if you notice, we took that million, I divided it into 10, and one of those would be 100,000. Now let's see what that actually looks like. Okay, I'm going to go ahead and write in 1 million. Okay, now I'm dividing by 10. Since I know each place value to the right is 10 times less, that means each one of these digits is going to shift one place value to the right. And this here, since it is a decimal at this point, I really didn't have to put this one in there. I did that just to show you the digits are shifting. So as you can see, 1 million divided by 10, we ended up with 100,000. All right. Now let's take a look this time at 10,000. So here, once again, I'm going to take 10,000. I'm going to divide 10,000 into 10 pieces. And when I divide 10,000 by 10, that means we're looking at one of them. And 10,000 divided by 10 would equal to 1,000. So once again, let's see what it looks like. I'm going to put a 1 in here for 1/10,000. And we're dividing by 10, so I know each digit is going to shift one place value to the right. And once again, I'm not going to write this one down because there is no decimal after, no digits after the decimal point except for 0. So now we can see 10,000 divided by 10 was equal to 1,000. Now, you need to be copying one of these examples down for division. Okay, and I'd recommend you copy one down for a whole number and one for a decimal when we get to that point. Okay, but that's up to you. I'm looking for two. Minimum at least one division, one multiplication when we get to it. Now, think about this one. 100 divided by 10. Think about what you know about what we've seen so far. What do you think the answer is going to be? But we're still doing pictorially right now. So I'm going to go ahead and do a picture. We have 10 of them. That represents 100. And we divided it into 10 pieces. So this 1 would equal 10. And we can see that by 100, dividing it by 10, so we know the digits are going to shift to one place value. And we can see that 100 divided by 10 will give us 10. Now, remember what I said about examples. This time, we're going to be dividing a decimal by 10. So, even though this is 1/10 right here, I'm going to sit there and take this 10th, and I'm going to divide it into 10 pieces. So if I divide 1/10 into 10 pieces, this one piece right here is going to represent 1/100th. Because I know 1/100th times 10 is going to give me 1/10. So this is going to equal 1/100th. And we can see that pictorially because I'm going to write the digits in. Now it's common to put a 0 in front of a decimal if there's no whole number, just so that we know it's a decimal fraction. Now each place value is going to shift one place value again. And we can see now that 1/10 divided by 10 equals 1/100th. Now let's go ahead and this time, let's take 1/100th. Well, we're going to divide that 100th up into 10 pieces again. And that means 1/100th divided by 10 is going to give me 1/1000th. Now let's see it with digits. And each digit is going to shift one place value to the right. And we can see 1/100th divided by 10 equals 1/1000th. So now you can see the notes on the right-hand side. What did we learn while we're doing this? Well, first, we know each place value to the right is 10 times less, or 1/10 the value of the place value to the left. Okay? So, because you can understand this, you say 100. The place value to the right is 10. That is 10 times less than 100. Now, if I'm looking at 10 and looking at 100, I know that 10 is 1/10 the value of 100. When dividing by 10, all the digits shift one place value to the right in order to get our answer. Okay, so this is what my book looks like. Okay, I'm going to keep the number 3 page for dividing, and I'm going to put multiplying on page 4. And you can see I've got a 10,000 divided by 10, 1/10 divided by 10, and I've got one more down below. Okay, and that's because one thing we've showed so far is just multiples of 10 divided by 10. What if I had other digits? Well, let's look. Now I have 6 divided by 10. Now let's use what we've been doing so far. I know that this is 6. Now if I divide 6 divided by 10, how many place values is that digit going to move, and in what direction? Just like we did before, this is going to shift one place value to the right. So we know 6 divided by 10 is equal to 6/10. How about if we divided it by 100? We haven't done anything like this yet. Well, let's think about it. This is actually like 6 divided by 10 times 10. Now, we said that every multiple of 10 shifts one place value. So here I'm going to divide by 2 10s. So how many place values do you think each is going to move? If you said 2, you're correct, because it's 10 times 10. So here I have 6 in the ones place. It's going to shift 1, 2 positions because I'm dividing by 100, which is 10 times 10. So the 6 is going to go 1, 2, right to here. Now I've got a hole here, but I really don't have a hole because I have imaginary zeros going out to the left, and I have imaginary zeros going out to the right. So this 0 actually shifts 2 place values. And then since it is a decimal fraction less than 1, good practice to put a 0 in front of it. So now we know 6 divided by 100 is 6/100. Now how about if we did by 1,000? What do you think? Well, we know that 6 divided by 10, and 10 times 10 is 100, and 100 times 10 is 1,000. So how many place values do you think each digit's going to move? If you said 3, you're correct, because here's 1, 2, 3 10s. It took for us to get 1,000. So let's put our 6 in our 1 spot, and we're going to shift it 1, 2, 3 positions. And we know we have to put placeholders in here, because in all actuality we have zeros here, which we just normally do not show. But they move 3 place values. So now we have 6 divided by 1,000 equals 6 thousandths. Now notice I didn't say thousand, I said thousandths. So when you're talking about decimals, if you notice it has the THS right up here. It goes 10, hundred, thousand, but since we're talking about decimals, it goes tenths, hundredths, thousandths. Okay, that lets us know it's a decimal. All right, so what did we learn at that point? Well, if you notice in the blue, it says when dividing by a multiple of 10, the digits move one place to the right for each multiple of 10. So as we saw for the example, 100 equals 10 times 10. So 6 divided by 1,000 would be 6 divided by 10 times 10 times 10, which equals 6 thousandths. The 6 moves 3 place values to the right because 1,000 is a product of 3 tens. Now pause the video if you need time to write that down. All right, so you can see my example here. I did 1 with a whole number divided by 10, 1 with a decimal divided by 10, and then I did another example just with a digit other than a multiple of 10, just so I could see it. Now, if you can see to the right, now I'm moving to multiplying by 10. I just use what we've learned so far. If I'm dividing by 10, the digits are going to shift to the right. Now, if I'm multiplying by 10, isn't the number going to get larger? So which direction do you expect them to shift? Since multiplying is opposite of division, wouldn't they shift to the left? All right, so let's take a look and see how that works. First one we have here is 1 times 10. Now, here is my 1. Now, I'm going to multiply that by 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we know that when we regroup 10, it's going to cause us to move one place value to the left. So now we know that 1 times 10 would equal 10. And let's see how this looks. Here's my 1. I know we're multiplying by 10, so the place value is going to shift one place value to the right. Now, once again, we have a placeholder here we need to move. But we're just taking the 0 that was here, and we're moving it one place value to the right. Okay, let's try another one. This time we have 100 times 10. So here I've got 100. But now I'm going to take and I'm going to multiply that 100 or copy it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we know that when we have 10, we have to move to the next place value. So we can see that 100 times 10 is going to equal 1,000. And we can see that because here's 100. And we're going to multiply by 10, so we know each digit is going to move one place value to the left. And I have an unlimited amount of zeros going out past the decimal point, which we can see now that 100 times 10 is 1,000. All right, let's do one more. So here I have 1 10,000. Okay, but we're going to multiply or copy that 10 times. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when we multiply and we get 10 in one place value, we know we have to move it to the next place value. So we can see now that 10,000 multiplied by 10, each digit is going to move one place value to the left because it's going to get larger. Now, when I get to here, we've got this imaginary 0 over here. Not really imaginary, but they're there. We just normally don't write them down. And we can see that 10,000 times 10 equals 100,000. All right. Now, look at this. Oh, now we're down to the tenths. I have 1/10 right here. But that's not going to make much difference, for our strategy is still going to work the same. Now, the difference is, how many of you have been told from the beginning that when you multiply by 10, all you do is put a 0 at the end of it? Okay, I know I was told that. How many of you were told that? Now that worked up to this point. Let's try something. I'm going to put a 1 right here. There's my 1/10. Okay, and I'm just going to put a 0 behind it because I multiplied by 10. Did I really change the value? We know when we multiply by 10, the digit should shift one place value to the left. Did the digit shift one place value to the left by adding a 0? No, it did not. Okay, so some of you are going to do that. I really hope not, but we'll see. Once again, here we have 1/10. We're going to multiply it by 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see we have 10 in this place value. So we have to move it one place value. And we end up with 1/10 times 10 equals 1 whole. Let's see if that works. Here I got 1/10. We're multiplying, so we know it's going to get larger. Each digit shifts one place value to the right. And I don't have to move this 0 because we don't usually show the zeros after it. All right, let's try another one. This time, I've got 1/100th. And we're going to multiply that by 10. And now that we've multiplied it by 10, we have to move it one place value. So we can see that 100 times 10 is equal to 1/10. And let's see this in real life. We know it's going to get larger. So we're going to shift one place value to the left. And it's common practice to put a 0 in front of a decimal fraction because we know it's less than 1. All right. Now, what did we learn from that? When multiplying by a multiple of 10, digits move one place value to the left for each multiple of 10. Okay? Example, 100 equals 10 times 10. All right. So here are the examples I have. Now I've multiplied by 10,000 times 10, 1/10 by 10. You notice I have one more down below. That's because just like in dividing, we've shown multiplying and dividing by a multiple of 10. But what if the digit's not a multiple of 10? Let's see. Here now I have 4. So I have 4 ones. And if I multiply that by 10, I know most of you all can go right up and say, that's 40. Well, let's see if that works. We know multiplying by 10, so the digits are going to shift one place value to the left because it's going to get larger. And I have that 0 here. Voila. 4 times 10 is 40. Now, what if it was 4/10? Well, once again, we're just multiplying by 10, so it's going to shift one place value to the left, and we're going to have 4/10 times 10 equals 4. Now we have 400ths times 10. So, okay, the 4 is going to move. And my 0 is going to move. And I can see that 400ths times 10 is 4/10. And just to show you one more time, this time we're going to multiply by 100. Remember when we divided by 100? Because we know 4/10 times 100 is actually times 10 times 10. So there's one place value, two place values. So the digit is going to move two place values to the left because it's getting larger. So 4 goes 1, 2. Now we have a 0 here, so it is also going to move 1, 2. So we can see that 4/10 times 100 equals 40. What if I did it by 1,000? Well, we know 4/10 times 1,000 is actually 10 times 10 is 100 times 10 is 1,000. So it's going to be 1, 2, 3 place values. So our 4/10 is going to move 3 place values, 1, 2, and 3. Now, we actually have zeros over here, even though we don't normally write them in. And it's just to show you that it's going 1, 2, 3, and 1, 2, and 3. So we can see that 4/10 times 1,000 is equal to 400. All right, so there's our example. 4 times 100 equals 4 times 10 times 10, which equals 400. The 4 moves 2 place values to the left because 100 is a product of 2 tens. All right. Now, what about if we have more than just one digit, though? Is that really going to change what we've been doing? We've been moving zeros, so let's see what happens. If I have 2 and 43 hundredths, okay? We know we're multiplying by 10, so it's going to get larger, and it's going to move. It's going to be 10 times larger because they're going to move 1 place value. So the 2 comes to here, my 4 comes to here, and my 3 comes to here. Notice when I write the answer up here is 24 and 3/10. I have the exact same digits, 2, 4, and 3 in the same order. All that happened are the digits moved. Okay. You should never, when you're multiplying by 10, 100, or 1,000, you should never have different digits. The digits should be the same. Your decimal point is just going to be put in a different place because of the digits moving. All right. What if we did by 100? Well, we got 243. We know that 100 is actually 10 times 10. So with that, we know that's 2 place values. So the 2 will go 1, 2 place values. The 4 will go 1, 2 place values. And the 3 will go 1, 2 place values. So we can see that 2 and 43 hundredths times 100 is 243. Let's do it one more time. Think about it. How many place values is the digit going to move? Well, it's 2 and 43 hundredths times 1,000. And we know that's 10 times 10 is 100 times 10 is 1,000. So how many place values is it going to move? 1, 2, 3. And it's going to get larger, so they're going to be going to the left. So let's go ahead and write it in, 243. And we're moving 3 place values, 1, 2, 3. 1, 2, and 3. 1, 2, and 3. Oh, remember the 0 over here, 1, 2, and 3. You have to fill that placeholder in. So now we know that 2 and 43 hundredths times 1,000 is 2,430. Okay, so let's wrap up. What did we learn? We know when we're multiplying by a multiple of 10, the digits move 1 place value to the left for each multiple of 10. So 100, which equals 10 times 10, so the digits move 2 place values to the left if multiplied by 100. Now when dividing by a multiple of 10, the digits move 1 place value to the right for each 10. So 1,000, which equals 10 times 10 times 10, so the digit moves 3 place values to the right if divided by 1,000. Okay, so here are my notes. Okay, these are my examples I did. And you notice I've got 6. Like I said, you have to do a minimal of 2, one for dividing, one for multiplying. Well, you may want to do more than that. That's up to you how many you do. Okay, but I just expect you to do a minimal of 2. So that's it for this lesson. Now I've taken a little bit more time. The videos, I usually try to keep about 15 minutes, okay? Now there's short questions in between, which you have to answer. That's so I can see it. Tomorrow when you come in, you show me your notes, or if you're online, you have to send them to me through Dojo. and then we'll work out the problem set. Okay? All right. See you tomorrow.